In this section, we're going to be talking about cubics, and in particular, factoring of cubics. Now, to begin this, we're going to actually look at a formula that is used when factoring cubics. It's called the difference of cubes. So you'll notice in this picture, I have a large cube with sides A, and there's a chunk taken out, and that chunk was made up by a smaller cube with side lengths B. So if we think about the volume of three-dimensional figures, the volume of rectangular prisms is found by taking its length times width times height. So if we had had the whole cube with side lengths A, it would have had a volume of A cubed, because A times A times A. The smaller one with side lengths B would have been B times B times B, or B cubed. Now what we want to find out is what's left when those pieces are removed. So we have this split up into three different sections. The bottom section I'm calling section 1, taking up this whole base of what's left. Now, you'll notice that the length here is A, and the width here is A, so I have A times A, now times the height. The height doesn't go all the way up A, from here to here is B, so what's left is going to be A minus B. For volume 2, this back figure here, this one goes all the way across in the back, comes across this way, but not all the way, and so we have something that looks kind of like this. This length going all the way across in that back would be A. From here to here, that's that height of the cube that was removed, that's B. And from here to here is just A minus B. So we have A times B times A minus B. Now the third figure is this smaller one, and it goes from here to here, here. So all we need to do is find our dimensions of that third figure. This is B, B, and this is A minus B. So I have B times A minus B. So to find the volume of this whole figure that's left when I remove B cubed from A cubed, I'm going to add up those three volumes. So that would be, well, A times A is A squared times A minus B. A times B would be AB. B times B would be B squared. Now, you'll notice that I have the same parentheses, same factor in every single one of these terms. It's sort of like if I'd had A squared times something plus AB times that same something plus B squared times that something. Now knowing that, if it had just been a variable or a number, you can factor it out. Like here, if it had been a B, we could just factor out the B and leave what's left. You can actually do the same thing when it's a parentheses that is being shared. So that would have given me A minus B times A squared plus AB plus B squared. What we have just done is proven or found the formula for the difference of cubes. So let's go back onto this side and write down the difference of cubes. formula is a cubed minus b cubed. And that is going to factor into a minus b times a squared plus ab plus b squared. Now there's actually another formula that goes with it. It is called the sum of cubes. The sum of cubes is found by finding if you have a cubed plus b cubed, it is going to factor into a plus b times a squared minus ab plus b squared. Now something to note here, these trinomials that are part of the factors are what we call prime. That means they don't factor anymore. So once you've factored into these two parentheses, you're going to be done. This is nice. So let's look at some examples. Example 1, x cubed plus 8. Okay, so I know that's something cubed. Can I rewrite 8 as a perfect cube? Well, that would be 2 cubed. Now, I have something that matches the sum of cubes. It's got a plus something cubed plus something else cubed. So in for A, I'm going to put the x, and every time I see a B, I'm going to put a 2. So this is going to factor into, so this will be A plus B, so it's going to be x plus 2, A squared, for ours that's x squared, minus A times B, so that'd be x times 2, or 2x, plus b squared. 2 squared is 4. This is prime. It does not factor anymore, so we are done. Number 2. 2 minus 128y cubed. Now, 2 isn't a perfect cube, and neither is 128, but I do notice that both of those are even. What that tells me is that there is a greatest common factor of 2. We are going to factor that 2 out. That gives me 1 minus 64y cubed. Now, let's rewrite it as perfect cubes. Well, 1 is easy. That's 1 cubed. But over here, we have to really think about it. 64 is 4 cubed. And y cubed, well, of course, that's y being cubed. So this is really 4y cubed. 4 cubed is 64. Y cubed is y cubed. So what's going in for A is the 1, and B is 4y. The whole thing of 4y. Not just a 4, not just a y, the whole thing. Alright, so we're going to be using the difference formula because that's a minus. Now the 2 we factored out does stay on the outside. In our first parentheses, we're supposed to have a minus b. Well, that's easy. That's the 1 minus 4y. In the second parentheses, it says to take a and square it. Well, a was 1, so 1 squared is 1. Now it says to put a plus. A times b. 1 times 4y. Plus b squared. Well, b is 4y. So if I take 4y and square it, 4y times 4y, that gives me 16y squared. Done. Last one on the sum and difference of cubes. And we probably need to pay attention for our greatest common factor. If I look at the coefficients, they don't have anything in common, but the variables do. There is at least an x in each one of those terms. So I'm going to factor out an x. That leaves me with 125x cubed minus 27. It's going to give me an x. And then I need to rewrite those as perfect cubes. What cubed would give me 125x cubed? Well, 5 cubed gives me 125, and x cubed gives me x cubed. So 5x together would give me, if I cubed it, would give me 125x cubed. To get 27, I need to take 3 and cube it. So my a in the formula is going to be 5x, and b is going to be 3. The x got factored out of everything, so it still stays on the outside. In the parentheses, the formula says to take a minus b. Well, a is 5x, b is 3. The next parentheses start off with a squared. So if I took 5x and squared it, 5x times 5x gives me 25x squared, plus a times b, 5x times 3 is 15x, plus b squared. 3 squared gives me 9. And we are done.